Hey, math friends. So our learning target today is that I can find unknown measures in similar figures. So we're going to still talk about cross products. We're going to talk about setting up that t-table, but today it's going to be related to any sort of like geometric figure, the relationship of corresponding parts. All right. So congruent is a term you've heard before in your life. Congruent, we're talking about the same shape, same size, exact same figure. Sorry about that. So that's pretty simple to see that the sides are the same, the angles are the same, exact same figure. But our work today is actually going to be, what about when something's similar? So we have the same shape, but a different size. And when that happens, we can say that the angles and the side lengths are proportional to each other. So we can set up that t-table, take cross products, and find unknown values. So it's the same exact 3 steps we've been doing the last 2 days. So I'm not going to go through those notes. It's just a matter of working in geometric figures. So our first example is this one. It looks like I forgot to erase when I made my last video. What is the height of the flagpole is the unknown there. So the first thing we're going to do is we're going to identify that we have similar figures here. So we have some similar figures. I am having trouble here with this pen. We have some similar figures. Eventually, if the pen works, we're going to be there. So we have this triangle here. We have the height of the flagpole is unknown. The shadow length of the flagpole is 28. That's my big figure. So in my big figure, I have that the height is X and the shadow is 28. All of that goes in my big figure section. Now, this isn't the only way to set it up. This is just how I started to set it up. So now, in my small little triangle here, I have a 5-foot person with a 4-foot shadow. So my corresponding parts then is that we would say that the height of the flagpole corresponds to the height of the person. So X corresponds with 5 feet. The shadow length of 28 corresponds with the shadow length of 4. Our job is to solve for X to find the height of the flagpole. Multiplication. So now, if you're not quite sure why I put things where they are, I'm going to quick review. This is the height of the flagpole, unknown. This is the height of the person. This is the shadow of the flagpole. This is the shadow of the person. So I put them in corresponding parts in corresponding places. All right. So just a quick review of like where did I get that in case you're confused. You can always rewind that video too if that helps. All right, so let's multiply that out here. So when we multiply that out, we get 4 times x equals 28 times 5. Should have probably grabbed that calculator here, but 28 times 5 is 140. Divide by 4, copy paste. So we get x equals that the height of the flagpole is 35 feet. So height of flagpole is 35 feet. Now, I recognize that from the beginning, and I didn't mention it at the beginning, that many of you could have said, Ms. Volkman, that was super easy from the beginning. I didn't need to set up all of that work. But I am going to do that because it's our learning target. So some of you maybe recognize, well, that's multiplied by 7, so that's multiplied by 7, so that has to be 35 feet. Just recognizing a pattern there. That's super awesome if you got that, but if not, that would be the other way to get it when we don't see that super awesome pattern. I'm going to skip this question for right now, and I might come back to it. Let's do this problem here. Corresponding parts to corresponding angle and corresponding angles. We have a small figure and a big figure. So we have small and big. In my small figure, I have 6 meters and 8 meters. They both are in the small figure. So now we're going to line up the corresponding parts. So this has my 6 goes with the 9. So 6 and 9 correspond with each other. 8 then corresponds with X. So 6 and 9 correspond. 8 and x correspond. Taking cross products, multiply where the x is, so we get 6x equals, multiply, 9 times 8 is 72, divide by 6, copy, paste, copy, paste. So we find out that the x value is equal to 12. The units is meters, 12 meters. So that unknown value is equal to 12 meters using what we know about similar figures. All right, so let's go take a look at the next example. I'm going to erase this just so I have some space to write. In my next example then, I have two triangles here. I have a triangle out front and I have a triangle in the back. So just be aware of that. So the red one we're going to call the small triangle and the blue one we're going to call the big triangle. So we have small and we have big. All right, I'm going to erase all that and then I'm going to separate them for you so that you can kind of see what I'm talking about. All right, so this right here is that smaller figure, okay? So if we take a look at that, the small figure has side lengths of 3 as the base and 4 as the height. The base of the big figure is all of this, all of that, which really is 3 plus 8 or 11. So the 3 in the small figure corresponds to the 11 in the big figure. The 4 in the small figure corresponds to the unknown height in the big figure. So that's our setup. So 3 corresponds to 11. 4 corresponds with x, same position. So corresponding means they're in the same spot. So we have 3 times x is equal to 4 times 11. Divide by 3, copy, paste, copy, paste. So we end up with 44. Divide by 3 gives us 14.6 repeating. So we have 14.6 repeating. Trying to write here. So I'm going to say 14.7 just for sake of being able to cut that off. So 14.7 feet is the height of that tree using cross products. All right. Let's take a look at another question. So here's a picture of my boys when they're little. These are the Volkman boys. We had this picture and I wanted to turn it into wallets, let's say. So I knew that the original picture that I had was 11 inches by 8.5 inches. So in the big figure, I have 11 inches by 8.5 inches. How does that compare to the small figure? Well, if we look at the relationship there, the 11 inches is right here. That would correspond to what? It would correspond to x. The 8.5 inches would correspond to 2 inches. So the 8.5 inches in the big figure corresponds to 2 in the small. 8.5 and 2 are in the same spot. So we line them up on in the base. Okay, so taking cross products and solving then, we get 8.5x is equal to 22. So as I solve for x, I divide by 8.5, copy, paste, copy, paste. We're looking for what does the new width of my wallet size have to be in order to keep it proportional. Now it's important that we keep it proportional because otherwise, if we stretch it too long or too high or too small, my kids' faces maybe would look a little distorted, right? So we have to make sure that how we shrink it on the height has to be proportionate to how we shrink it on the width. So that would be 2.59 inches. 2.59 inches would be what we need the width to be in order to keep the picture we want to make sure it doesn't look distorted. So that we would want to make sure we shrink it at the same proportional relationship. So there's a great example of when we would reduce a picture and how would we keep it proportionate from height and width. Likewise, another example. Who is this cool person? So if we take a look at this awesome picture, it says that the original photograph had a height of 4 inches and a width of 6 inches. So this was 4 inches and 6 inches. So if we take a look at the small figure, we recognize that that is 6 and 4. 6 and 4. If we make this in a large poster size in my classroom, because it's so awesome, we would have to figure out how much do we need to make the height. What is the new height? Well, 4 is the old height. The question is, what's the new height going to be? That's my x. So 4 and x are in the same position. The width is 6 here, which would go to the width of 10 here. So then we simply would take cross products and solve. So we get 6x equals 40. We divide by 6, copy, paste, and we end up getting that we would want to change the height of that photograph so that it's not distorted to 6.7 inches. And by doing so, then it would keep it nice and proportionate. Whoops, that was the height. The height then would be 6.7 inches. So that's how we would deal with similar figures when we want to shrink something or grow something or we're looking at a shadow. Let's take a look at this next question, the lighthouse problem. Small figure, big figure. Clearly my unknown is what's the height of the lighthouse. So my small figure, I have 8 for the height and 2.5 for the width of the height of the lighthouse. If we talk about corresponding parts, the height of 8 corresponds with the height of x. So they're corresponding, they go in the same position. The width of 2.5 corresponds to the width of 10, so they go in the same position. Taking cross products then, we're going to multiply across, so that's 2.5x equals 80. We're going to divide by 2.5, copy, paste. And what we're looking for here is what is the height of the lighthouse. So we would have 80 divided by 2.5 gives me 32. Now, we don't have units listed, so I'm just going to say 32 units. So the height of that lighthouse is 32 units. I assume feet, but we'll go ahead and just call it units for now. All right, guys, we're at the 12-minute mark. And the last problem of the day is this determine the height of the car problem. Why don't you pause the video and give this one a shot, see how you do. So we have small and big. So we have small, big. We have 3 to 5. The height of the car corresponds to the height of the enlarged car. I guess they're both cars, right? So that would be, right now, we would call that x. So they're in the same position. Same position. I want to circle that because I don't want you to think we're multiplying there. The width of the car is 5, which would correspond to the width of the large car, which is 12. Now that we have them lined up, we take cross products. So we get 5x. So we get 5x. Well, maybe we do. We get 5x equals 36. Divide by 5, copy, paste. What we're looking for is the height of the car. Again, units aren't listed, so we will assume feet again. So we have 36 divided by 5 gives me 7.2, and we'll just call it units because I'm not quite sure which is being represented. I assume feet. So the height of that car is 7.2. All right, so in summary today, our learning target is basically about similar figures. The idea is basically if you have a big triangle and you have a small triangle, that you line up corresponding pieces. So big triangle compared to small triangle. You could line up corresponding pieces. So if 5 goes with 2, we line them up. And if 12 goes with x, we line them up. And then we take cross products. So that's the key of today's work in corresponding parts. The only question I skipped was this one. And the only thing that's going on in this question is really that this triangle needs to be rotated. It just needs to be rotated. So if we were to set it upright, we would have 9 as the base and x, and then we would still keep this 8 and 5, and then we would just set up our corresponding parts. That's why I skipped that question when I did, but I don't want the video to go too long. So that is the lesson for today on similar figures. Have a glorious night.